Hi everyone. So today we are going to take a look at the 88th question on Leetcode, and we are doing this top interview 150 question series. Now let's go through the problem statement. It basically says that we are given two integer arrays, nums1 and nums2, which are in sorted format, and we are also given two integers m and n, which are representing the number of elements present in nums1 and nums2 respectively. We need to merge these two arrays into a single sorted array, and that should be in non-decreasing format. So that means it should be in sorted format, increasing order. Now we do not need to return anything, but instead we can just move the elements from num2 array to nums1 itself, and that would do the job. Let's take a look at example now. We are given three elements in nums1 array. So these are all in sorted format. And then there are present some zeros. And at the place of these zeros, we need to move these elements. And we need to make sure that overall array, after merging these two arrays, it needs to be in sorted format as well. And we are given this n, which says that there are three elements present in nums2 array. And these are few other examples. And then there is an follow up as well. So it says that if we can run this algorithm in O of m plus n time. So this is our final time limit. So we need to make sure that at the end we reach this particular complexity. Now let's try to find out the solution. The first solution which we have is a simple one. We can just move these elements from here to here, and at the end we can sort this array and we are done, right? That would make sure that all of the test case passes because we are giving them an correct result. But the complexity in this particular case will be n log n because we are performing a sorting operation. The other technique which we have is two pointer technique. Now two pointer technique on this question can be applied from two ways. Either we can apply it from front end or we can apply it from back end. Now if we try to apply it from front end position, then at some point we need to kick off a few elements. The case could be like this. So let's just say we have this 2 2 2, then there are few position left for the num2 array, and in num2 array we have these elements. Now we need to kick off all of these 2's to move these numbers here, right? And if we are moving these numbers, let's just not make it 2 2 2, let's make it 2 3 4. Now if we are moving all of these elements, if we are kicking them out from these positions, then we need to store them somewhere. And if we are storing them somewhere, we need to make sure that they are always in sorted format, because we need to add these elements here as well, and we need to add them here in sorted format. So we want to make sure that wherever we are storing these elements, we are storing them in an sorted format. What could we do to store them in an sorted format? We can use multiset or we can use priority queue, right? So these two data structure will make sure that these elements are stored in sorted format, right? But the issue is this solution comes at an extra cost of storing these elements in sorted format. Priority queue or basically multiset, both of these data structure also need an extra time to make sure that these elements are in sorted format and stored in sorted format and we can access them easily. So this is not an optimal solution. Now let's take a look at the other approach which we had, two pointer technique from backend. So we are going to start from backend. Now if we are doing it from back, then we have an advantage, and the advantage is that last position is always blank. So if we are going to move or swap an element, we do not need to kick off anyone. We are sure that particular position will be always empty. So in this particular case, if we need to move either 3 or 6 at this position, it's already empty. And if we are moving some element here, then we are also clearing up space for sorter element to be accommodated easily, right? We will start from the backend and we will move the element accordingly. So if whichever element is larger, we will move it here. Now a few other things which we need to make sure is we need to exhaust nums2 array. If we somehow exhaust nums2 array and we are sure that our logic is correct and it will always store the element in sorted fashion, then we are done, because we have already exhausted this nums2 array. That means all of the elements are present here and nums1 array element are already there. So, and we are also saying that our logic is correct. That means we have stored the elements in unsorted format. So we can just done. We can just return, right? So let's try to code it. We need three pointers. One is I, which will point the last element present in nums1 array. So this will be m minus 1. Then there will be an j, which will point the last element in the nums2 array. And then there will be an k, which will point at the last position where we need to move the element. So pointer k is going to point the position where either we are going to move the element present at j position or I position. There will be an while loop, and our final target will be to exhaust nums2 array, because the moment we're done with it, we are sure, then we can just return, because our logic is correct and it will store the element in sorted fashion. So we need to make sure that somehow we just exhaust nums2 array, and there will be our logic. So here, now in this particular case, let's just see, these elements are going to be moved here, right? So all of these elements will be shifted here, and the moment we done do this, we are kind of exhausting the elements. We are exhausting this limit, that we are done with the element which were present in nums2 array. Now in that particular case, we can't just check for the larger element. We just need to move these elements here, or in this particular case, these elements we just need to push here without making any comparison, because we are already exhausted nums1 array, right? So we need to make sure that there are a few elements present in nums1 array to make the comparison. If this element is larger than the element present at j location in second array, then we will push this element at the end, right? And similar way, if that's not the case, then this will store the element present at j location in the second array, right? Now we need to move the pointers as well. So if we fill this position, then we need to move to this position. So here we can see that we need to decrement. And if we are using this 3, then we need to shift to this 2, right? So we need to move the I as well. If you are using ith element, then we need to go to the I minus 1 position. Similar way, we need to go to j minus 1 position if you are using jth element in nums2 array. And we are done here. This array will be automatically exhausted, because that's the condition here. We are not going to exit this loop if we are not exhausting this array. And let's try to submit this particular solution. So test case is passed, and let's try to submit it and accept it. Thank you for watching, and see you in the next question.